Today's lesson is from 1.3 in our textbook, and the topic is algebraic expressions. So the goal is to interpret parts of an expression, such as terms, factors, and coefficients. So we'll start out with an investigation. During the summer vacation, you work 2 jobs. You walk 3 dogs several times a week, and you work part-time as a receptionist at a hair studio. You earn, let's highlight this, you earn $8 per hour as a receptionist and $20 per week per dog. Your weekly schedule shown below is the same each week. How much will you earn in 10 weeks? Explain. So this is a great example of solving a simpler problem. If we can just figure out in 1 week how much we would earn, then we can easily multiply by 10 to find out how much we would earn for 10 weeks. So let's start looking specifically at dog walking. We know how much we earn for dog walking. So how many dogs are we walking? It doesn't matter how long it takes us, it only matters how many dogs. So walk dogs 8 to 9. Looks like there is one occasion. Here on Wednesday there's another occasion. Here on Friday there's another occasion. So it looks like each week, Monday, Wednesday, and Friday, we would walk dogs. So since there are 3 occasions and we earn $20 each time, we would earn $60 per week walking dogs. The next question is, how many hours, since working as a receptionist is an hourly rate, how many hours are we working as a receptionist? So you see here at the studio 1 to 5. So that's the same for 4 days, 1 to 5. So that's 1 to 2, 2 to 3, 3 to 4, 4 to 5. So that's 4 hours times 3. So there's 12 hours. And then we have another 4 hours here for a total of 16 hours. So we would say receptionist, we have 16 hours and we make $8 an hour, so $8 times 16 . Let's see. Sorry, I did not do that right. It was 4 days and 4 hours per day, so it's 16 hours, not 12. And then 4 more would be a total of 20 hours. So therefore, we would have 8 times 20, $8 an hour times 20 hours is $160. So then we could combine the $60 and the $160 to get $220 per week. Multiply that by our 10 weeks, and we would end up with, in our summer, $2,200. Not bad. So to model a situation with an algebraic expression, do the following. Identify the actions that suggest operations. Define one or more variables to represent the unknowns, and then represent the actions using the variables and the operations. So let's look at example 1. You start with $20, and then you save $6 each week. So you can see here the saving each week is our action, so we'll define the variable W for week. And we can write an algebraic expression modeling the total amount saved. $20 stays the same. That's how much we start with. So we might say 20 plus $6 times the number of weeks, and that would be your algebraic expression. Example 2, what is the value of the expression for the given values of the variable? So this is a practice and review of substitution. If A equals -4 and B equals 5, what would the total value of this expression be? So we plug in -4 for A, 5 for B, and then we simplify. I highly recommend writing these out because it's easy to make simple mistakes when you're not working it out carefully. -4 plus 4, order of operations, we do parentheses first, and that's 0. 0 times 7 is 0, so I'm just going to cancel that out. That whole thing is 0. And then 3 times 5 is 15, minus 8. We go to left to right when we have addition and subtraction. So 15 minus 8 is 7. Separate these out a little bit. Next we have x is 1 and y is 1. We're going to find the value of this expression. So 1/2 plus 1 squared. Order of operations, we do exponents first. 1 squared is 1. So 1/2 plus 1 equals 1 and 1/2. For part C, last one, we're substituting in a 6 for x and a -3 for y. This one, pay close attention. When we have a negative value and we are squaring that, it is super important that you put that negative value in parentheses. So we have the -3 squared inside the parentheses is going to be a total of 9. -3 times itself is a positive 9. 6 squared is 36. So let's go ahead and write that as 2 times 36 minus 9 over 3. 36 minus 9 is 27. So we have 2 times 27 over 3. So we next can do 2 times 27 and then divide by 3, or something that's a little bit simpler would be to simplify 27 over 3 first. We know 27 divided by 3 is 9. So I'm going to go ahead and reduce and do 2 times 9, which is 18. And again, it would work either way. If we did 54 divided by 3, we get 18. That would be multiplying first and then dividing, or like we did here, we reduced first. Example 3, in basketball, teams can score by making 2-point shots, 3-point shots, and 1-point free throws. What algebraic expression models the total number of points that a basketball team scores in a game? Okay, so there's our first question. There's multiple parts. If a team makes 10 2-point shots, 5 3-point shots, and 7 free throws, how many points does it score in all? So we're going to start off by defining some variables here. Teams can be scored by making 2-point shots. So we'll call 2-point shots W for TW2. So that's 2-pointers. 3-point shots, let's call those R, 3-pointers. And 1-point shots, so let's call that N, just so we don't get confused with the O and the 0. 1-pointers. So let's go ahead and set up our algebraic expression. 2-point shots. So 2 times the number of 2-point shots would give us the total score for 2-point shots. 3 times the number of 3-point shots. And 1 times the number of 1-point shots. So there's our algebraic expression. And then the second part here asks us to go ahead and plug in values. 2-point shots, how many 2-point shots, how many 3-point shots, and how many free throws. So we'll go ahead and plug that in. 2 times 10 plus 3 times 5 plus 1 times 7. So we get 20 and 15 and 7. 20 and 15 is 35, plus 7 is 42. And lastly, here in example 4, we're going to review simplifying algebraic expressions by combining like terms. One great method for doing this is, since we have different variables and looks like we have the same values for exponents, that is what defines like terms, having the same variable with the same value for an exponent. So it looks like we can combine 7x squared and minus 4x squared, and then maybe do a different symbol to help identify the other like terms. The 3y squared and the 2y squared are like terms. So let's do 7x squared minus 4x squared is 3x squared, and then 3y squared and 2y squared is 5y squared. Next, we can't combine like terms within the parentheses. There aren't any like terms, so we'll first have to start by distributing to get the terms out of parentheses. So we have a negative 3k minus, the negative distributes, minus m, and then distribute the 2, so it's plus 2k, and then minus 8m. And now we can actually combine like terms. So we've got the negative 3k and the 2k for negative 1k, or just negative k, and then the negative m and the negative 8m for a minus 9m. And that is our lesson on section 1.3, algebraic expressions.